Listen, can anybody define what is half-life? You studied this in +2. Who is the topper in +2? Raise your hands. Don't raise. Okay. Studied in +2. What is the half-life? Define it. Listen. If I have 500 mg of drug with me, I have 500 mg of drug. Half-life of this drug is 8 hours. Assume we have 500 mg of drug. Half-life of this drug is 8 hours. After 8 hours, what is the concentration left? Half-life is 8 hours. After 8 hours, what is the concentration less? Initial is 500. 250. So define now. See, you should learn. We have something written. Seeing this, you should be able to define it. It is defined as time taken to reduce half of initial concentration. That's all. We are thinking so much. Half-life is defined as time. You are saying life. So you need to describe the life in terms of time. So I am using the first word, time taken. So time taken to reduce the concentration to half of initial concentration. Time taken to reduce the concentration to half of initial concentration. It's called half-life. Okay. The half-life of drug is 8 hours. In 8 hours, it is going to degrade half. How much time it will take to degrade full? Question asked in interview. People said 16 hours, they kicked him out. Wrong. How for? If you say anything, you should say me the reason. Okay. Next half-life. What is the concentration in next half-life? Then how it is 0? You said 16. In 16 hours, it came to 125 from 500. What is the next half-life? 60 something. Then 30. Then so how much time it will take to degrade? How many cycles? 1, 2, 3, 4, 5, 6. Still it is there, na? 7 is there, 3 is there, 1.5 is there. Where you should stop? There is no stop here. You can write this much big. Where you should stop until you can detect that. See, how will you saying the drug is present? You are taking some methods, analytical methods. You are setting the analysis. Some analytical. Let's say you are having drug. You are analyzing it with titrimetric method. So titration, the color is changing. You are saying at some point you can't detect the drug. Your color won't change. It remains as such. That point we can say that drug has fully degraded. But still drug is there. But you can say fully degraded. So generally it will take 9 to 10 cycles. Don't say hours. Cycles. One cycle here is 8 hours. The drug half-life is 8 hours. If the drug half-life is 5 hours, then how many cycles? 8 hours, 10 cycles. 5 hours? 10 only, yes. 5 hours also 10 cycles. No difference. Okay. This is what the problem with. This is what the problem is with radiopharmaceuticals. Not only pharmaceuticals, all radioactive elements. Radioactive elements have vast half-life. They will degrade till 5000 years also. They will keep on degrading. So for that we should have some equation. So half-life of radioactive material is 0.693 by K. What is this K? Constant. Which constant? The radioactive material is degrading. Okay, the radioactive material is degrading. Hence we call it as degradation constant. This is called as degradation constant. Now, how we get this equation? Where we get this equation? You saw this equation is +2. Okay. We have zero order kinetics, we have first order kinetics, we have second order. Have you heard this? Order of reaction. Zero order reaction, first order reaction, second order. Which order the half-life belongs to? I don't want to waste time. The half-life belongs to first order kinetics. What it is saying? See. Okay. I will double this. I will double the concentration. Now tell me how many cycles it will take. 10. So, means what? The degradation of drug is independent of initial concentration. The degradation of drug is independent of initial concentration. See, zero order kinetics, C naught by 2K. Second order, C naught by, 1 by C naught K. Zero order. Zero order, we have C naught by 2K. Half-life is C naught by 2K. Means what? Half-life is directly proportional to initial concentration. Here it is inversely proportional to initial concentration. Here it is, there is no initial concentration. Hence it is independent of initial concentration, which can be proved here also. 10 cycles and 10 cycles. You take any concentration, it is the proof. Okay, it is the proof that it is not depending on the initial concentration. How we get this equation? There is a derivation. I am not going to tell this now. Okay, whenever we have free time, we will talk about the derivation of this. What you need to learn here is, in the concept of half-life of pharmaceuticals is, radioactive materials is, radioactive material degradation is not dependent on initial concentration. Okay, it will degrade in its own fashion. It is not dependent on initial concentration, and they will last for longer period of time. Reason? Because their degradation is not dependent on initial concentration, hence they will last for longer period of time. You take 1 kg, same degradation. You take half kg, same degradation. You take 100 grams, same degradation time. That's what you need to learn with half-life of radioactive materials. Do you understand? I explain once again, listen. In half-life of radioactive materials, what you need to learn is, this radioactive materials will degrade by its own fashion. It is not dependent on the initial concentration of your any radioactive material. It will degrade by its own fashion. It will take so much time to degrade. Reason? It is degrading by first order kinetics. Remember this. So, it is not dependent on initial concentration. It is degrading by first order kinetics. Hence, the degradation will take so much long time. That is the reason. Still now, you know, Hiroshima, Nagasaki, where the bomb is dropped, till now the radiation is there. Why? This is the reason. Because it will degrade very, very slowly. Next is very important topic, measurement of radioactivity. Measurement of radioactivity. A very, very important topic. Definitely will get questions from this. Different methods to measure. Okay, different instruments to measure. First instrument is, write down, ionization chamber. Quick. I will not give notes. I will just listen. My cup of tea is explaining the concept. That's all. Okay. If you want notes, I will give this cup to madam. She will tell the notes. I will not dictate the notes. I will just tell the concept. It's up to you how you will write your running notes. It's up to you. So, first one is ionization chambers. Ionization chamber. Who is Triveni? ionization chamber. Next is proportional counter. Proportional counter. Next, Geiger-Müller. Geiger-Müller counter, we call it as GM counter. Next, scintillator counter. Scintillator counter. Scintillator counter. Last one is autoradiography. Autoradiography. Listen, ionization, proportional, and Geiger-Müller. All three runs with same principles. All the three run with same principles. So, all these three counters I will explain at one part. Okay, I will explain at one part. Before that, we should know some basics. We have alpha, beta, and gamma radiations. We are using these instruments to measure these radiations. In this room, let's say that book is affected with radiation. This is Geiger-Müller counter. If I bring it near, it will give me sound. It will show me how much radiation is there. So I need to measure how much radiation is there. Somebody has worked in radiation center. If I come near to her, it should tell me how much radiation is there from that body. That what is the, so in this radiations we have three types of radiations. Alpha radiation is having high or low ionization power. Alpha, high ionization power, low penetration power. Okay, high ionization power, low penetration power. Beta has low penetration power than alpha, but it has high ionization. Beta has more penetration power, less ionization power. Gamma radiation is more less ionization but far more penetration. So we'll see about ionization here. Who is having more ionization? Alpha. Less beta. Further less gamma. We make use this. Sir, what do you mean by ionization? Why you are saying they are ionizing? Remember, if you keep alpha radiation to anybody, to the body or anything, let's say in the room we have gas. So we have gas here. I will keep alpha radiation into the gas. When I keep alpha radiation to the gas, it ionizes the gas. Let's say gas is X. It will be ionized. Once we ionize, what is the products? What is the product of ionization? Due to the resultant of ionization, what we will get? Ions. We get ions. So we get positive or negative ion. Now, if I can measure any one of this ion, then I can measure how much radiation is there, because depending on radiation only there will be ionization. More radiation, more ionization. Less radiation, less ionization. This is the simple basic principle, understand. Any radiation reacts with the gas and produce ions. Okay, positive ion and negative ion. Most probably it will knock out the electron from the atom. Let's say we have gas atom. When the radiation falls on the gas atom, whatever electron is there in the gas atom, it will be knocked out. So due to electron is deficient, it becomes positive. Here we have electron, so it will become negative. So due to ionization, we will get positive ion and electron. Due to ionization, we get positive ion and electron. That's what we are going to get due to the ionization. If I measure what is the amount of electron released, then I can say what is the strength of the radioactive material. That is your radiation, alpha, beta or gamma radiation. Okay, that what is the basic principle of ionization, proportional and Geiger-Müller counter. So how it is, how we are going to measure it, we will try to see. Because I want to attract positive and negative, so what I will do is, First we have one chamber. We have a cylinder. You have a metal cylinder. Sir, why metal? Because I want to attract these two. So I'll keep it as cathode, and in between I will insert a rod. Okay, in between I will insert a rod. This rod is kept as anode. That rod is kept as anode. Okay. If I am anode, I am positively charged or negatively charged?
Positive.
I am anode means positive charge. My name is given anode because I am attracting negative charges. Okay. Don't see this negative and tell me. First, your A section is quarreling with me. Okay. Don't do that. We have a metal cylinder. First, we have a metal cylinder. The charge is given to the metal cylinder is cathode, and we have a rod in between the metal cylinder. This rod should not touch the metal cylinder, hence we have an insulator. Around the rod we have insulator. Okay. Now, this this rod is attached to amplifier. This amplifier attached to display, which will display. Here we have a resistor, then we have something which can induce the voltage. Okay, remember the construction. Without this, see what is the principle here? Ionization of gas molecules is the principles. If I ionize the gas molecule, if I can measure what is the amount of electron released due to ionization, then I can measure what is the amount of radiation. What is the amount of radiation? That's what the topic is. Your ionization chamber, proportional counter, Gregor-Muller counter, same construction. We have a gas chamber in a cylinder. This cylinder is given cathode. Okay, and we have a rod in between the cylinder, that is given anode. It is connected like this. Here we have an option to increase or decrease voltage. We have an option to increase or decrease the voltage. We can increase or decrease the voltage. Now, once you two come here. Assume these are gas molecules. Okay, one molecule. Hold him. Hold him. Hug him. One molecule. Okay, listen. I am radiation. When I hit them, he is electron. He will go there. Okay, he will go at one side. Where he will go? Electron to the rod or to the cylinder? There where we called A section. Rod or cylinder, anode or cathode? Obviously to the rod. Hey, electron will be going towards the rod, and your positive ion, don't say proton, okay, positive ion is going towards the cylinder. So once we have radiation, when we hit it, we have positive and negative electron. This electron will go towards the rod, and this positive will go towards the cylinder, here or here, anywhere. It will go towards the cylinder. Come again. So I am a strong radiation. Okay, I am a strong radiation. What do you mean by strong radiation? Strongly I will ionize them. Means what? The difference between the electron and positive ion will be very large, and easily electron is attracted towards the rod, and it is showing the signal. Okay, it will show me the signal. Next. Now I am weak. Let's say I am alpha, beta, gamma. I am gamma radiation. So what I will do is, when I come and separate them, okay, when I come and separate them, the difference is not that much because I am very weak. Again they will rejoin. I am separating them, they are rejoining. What should I do so that he will be separated in case of gamma radiation? If I increase the voltage, so what do you mean by voltage is positive will become more positive, negative will become more negative. Okay, if I increase the voltage, obviously this electron will run towards anode very readily, even though the separation is very weak. Even though the separation is weak, he will run towards the anode very readily. That what the difference between, thank you sir, that what the difference between ionization uh, proportional and Geiger-Müller chamber. Here I said gas. The gas used is a inert gas argon which is 90%, plus we use alcohol, vapor of alcohol, ethyl alcohol or methyl alcohol, that is your 10%. Okay, gas used is 90% and alcohol used is 10%. Why alcohol is used, I will tell you later. It is acting as a quenching agent. What is that quenching agent? We will try to see later. Okay. Now, so how it will detect is, if I take, assume this is a Geiger-Müller, it is, this one is radiation. If I keep near, the radiation is high, it will give me waves like this. The radiation is low, it will give me the waves like this. Okay, radiation high, this is the wave count. One wave is one count. That is the reason we are giving counter. Why the name is given is counter? Because it is counting. Okay, what is the radiation? It is going to count. So one radiation, one wave is one radiation. It will count like this. Hence the name is given counter. What we need to see here is, if for ionization chamber, the name is ionization chamber. For ionization chamber, we use only 50 to 100 volts of potential. We use only 50 to 100 volts of potential. We will see what is the difference between applied potential and signal. This is signal. Okay, what is the difference between applied potential and signal? We will also see why the name proportional it is given. Why the name ionization is given? Because they are ionizing, hence the name is given ionization. Why the name Geiger-Müller is given? Two scientists find that, hence their name is given. But in between we have proportional. What do you mean by proportional? That we are going to see. So if you draw a graph, this graph is not there in the textbook. Whatever I am telling you, I have referred so many YouTube videos and so many textbooks. Okay, then only I got this. I shared 3 videos. Who saw this? I won't ask question, don't worry. If you saw that, did you saw this one which I am drawing? Signal and potential. Signal and potential applied. Okay. So initially what happened? Initially, even though if I apply potential only till this much, if I apply potential only till here, there is no signal. Why there is no signal? Because they are going to rejoin. Whatever the separated, they are again rejoining. So there is no signal. So even though I got this, further there is no signal. So potential increases, some sort of signal is there, but again it is going back. Some sort of signal is there, but again it is going back. That what is your rejoining area. Next is ionization chambers. When I give a signal of potential of 50 to 100 volts, when I give a potential of 60 to 100 volts, here there is no increase in sign. Potential is increasing, but the signal is not increasing. What is the reason behind this? We will try to see. Now, when the radiation hits your gas molecule, when the radiation hits the gas molecule, it will produce ions. It will produce ions. We call this as primary ion. It will only produce primary ions. No secondary ions are produced. What do you mean the secondary means? This will go and hit another gas molecule, again it will produce ion. In case of ionization chamber, if you apply only 50 to 100 volts, only primary ions are produced. Only primary ions are produced. This is the reason. See, from here primary ion is produced. Further if you apply primary, further if you apply primary. So there is no increase in the signal. You are increasing the potential, there is no increase in the signal. Why? After the break point of rejoining, this is the break point. After this point, primary ion is produced. Even though increase the potential, primary ion is produced. Even though increase the potential, primary ion is produced. Hence, there is no increase in signal, but there is increase in potential, because there is only primary ion is produced. Next, proportional counters. Now, when you increase your signal to 1000 to 2000, when you increase your signal to 1000 to 2000, proportionally, when you increase your potential to 1000 to 2000, proportionally signal is also increased. That is the reason we got the name proportional counters. What do you mean by proportional? How much I am reading, that much marks I am getting. Means what? My marks and my reading is proportional to each other. You got what I am saying? How much I am eating, that much I am running. So eating and running are proportional. How much the potential is increased, that much signal is also increased. Hence it is called proportional increase. Hence the instrument is called as proportional counter. It is counting the wave, hence we call it as proportional counter. Next, after proportional counter, okay, what happens in proportional counter is, why we are getting proportional counter is, we are getting secondary ions. Here we are start producing primary ions, primary. Here we produce secondary ions. Hence we are going proportional. Next, further if you increase the voltage, let's say till 3000. If I increase the voltage till 3000, okay, suddenly we will get avalanche effect. What do you mean by avalanche? What do you mean by avalanche? I don't know. Whenever there is snow is falling on the mountain, that snow will sit not tightly, it will sit loosely. One fine day, whole snow will fall down. That coming once or all at once, we call it as avalanche. Avalanche means bulk of the snow coming at once. So we see avalanche effect if we increase the voltage to 3000. If I increase the voltage to 3000, we see avalanche effect. Okay. Due to this avalanche effect, here once avalanche start, all gas molecules are consumed. Over. Further, there is no gas molecules remaining. All gas molecules are consumed. Hence, we get plateau here. This is plateau. So, in Geiger-Müller counter, we get plateau. This diagram is not there for you in the syllabus, but to understand what is the difference between ionization chamber, proportional chamber and Geiger-Müller, we need to know. Now, we will see this in a normal way. So, what I am going to tell you is, listen, come sit here, you come here. Yeah, first we tell this. This is used for alpha radiation, this is used for alpha beta, this is used for alpha beta and gamma. Initially, I use alpha radiation. Alpha radiation is enough to knock out the electron from the gas. Alpha radiation is enough to knock out the electron from the gas, because alpha radiation is doing so much work. For me, no need to increase the potential. No need to increase the potential. I will get the signal. Enough. Next, if we have beta radiation will do only some work, not as such of alpha radiation. In that case, what I have to do? I need to increase the potential. See, alpha radiation is doing so much work, hence I am not increasing the potential. Beta radiation is doing less work, so I am increasing the potential. Gamma is so much weak. Gamma is so much weak. Even though I am sending him, he will not go. That's what gamma is. In that case, what I have to do? I need to increase potential, full potential. So, if we use less potential, that instrument is called as ionization chamber. Because why the name is given ionization? Alpha radiation readily ionize the gas present in the chamber, hence we call it as ionization chamber. If you further increase, whatever the potential increase is directly proportional to signal. Whatever the potential increase, it is directly proportional to signal. Hence the name given to this instrument is proportional counter. Why the name is given? Because how many voltage, how much voltage you are increasing, it is proportional to the signal. The last one is Geiger-Müller. We use full voltage. Why? Because we want to measure gamma radiations. We want to measure gamma radiations. Now, you tell me, if I send you in a room, which type of counter you will take? If I am sending in you a room, there is radiation. I will ask you to measure the radiation. Which type of counter you will take? We have three instruments, IC, PC, GM. Which one you will use? Okay, what is the radiation present in the room? Do you know that? Then why you are selecting IC? IC is not detecting beta and gamma. Why you are selecting that? Now what you will select? GM. So you need to select Geiger-Müller counter. If you don't know the radiation, if you don't know what is the type of radiation, you need to select that Geiger-Müller counter. I repeat once again, listen. Ionization, proportional and Geiger-Müller, both are same instrument, only difference is application of potential, voltage, application of voltage. What happens, basics is when the radiation is interacting with the gas molecule, that radiation will ionize the gas molecule. In the process of ionization, it will produce a positive ion and it will produce a electron. If I can measure this amount of electron, I can directly say this is the strength of the radiation. If I can measure the amount of electron, I can directly say this is the strength of the radiation. For that, what I will do, I will construct an instrument. How the instrument is constructed? Outer metal, inside one rod will be there. Okay, the outer tube is given cathode and rod will be given anode. When the radiation enters the tube, when the radiation enters the tube, it will ionize the gas. The gas present in that is one inert gas and one quenching gas. Inert gas is argon, quenching gas is alcohol vapor. What is that quenching? I will tell you. Okay, alcohol vapor. Now, once the radiation enters into it, it will ionize. The electron will be going towards the rod and it will be giving the signal. Electron will be going towards the rod and it is giving the signal. This is what the working is. Now, for that electron to go towards the rod, if the separation is weak, we need to increase the voltage. If the separation is strong, no need to increase the voltage. If the separation is weak, we need to increase the voltage. So, in ionization chamber, the separation is strong. So, you need to have only less voltage. In proportional chamber, the separation is weak compared to ionization chambers, hence we need to increase voltage. In Geiger-Müller, the separation is so much weak because we are using gamma radiations also there. The separation is so much weak, Hence we need to use furthermore increase in the potential. Now, after the electron showing the signal, this electron again comes back and rejoin the positive ion. This electron comes back and rejoin the positive ion. It will complete the circuit. Okay, if you have studied this, you should understand. Okay, whatever electron we are using, it will come again. It will go back to its original position only. Only thing is, initially when electron is coming freshly, it has more energy. It will transfer the energy in the form of torch. Then it will again go back to the batteries. See, I will tell you like this. In the torch we have battery. In the battery we kept electrons with high energy. Okay, what it will do is, electron will come, lit up the battery, it will show the light, again it will come back to the battery. Now new electron will come. Like this, slowly there will be depletion in electrons. Electrons will be there in the battery, but the power will be not there. The electrons don't have power. So to complete the circuit, whatever the electron is coming here, again it is going back. When they are meeting, who? The positive ion and electron. When they are meeting, again they will show signal. When they are meeting, again they will show signal. This signal is called false signal. This is called false. Because we are not getting signal due to ionization, we are getting signal due to combination. False signal. To avoid this false signal, we use quenching gas. Quenching. To avoid the false signal, we use quenching gas. This alcohol will absorb that signal. 10% alcohol will absorb the signal. You won't get false signals. So what should you write? What define quenching? Quenching is stopping of unwanted signal. It's called quenching. What is the quenching agent you are using? Alcohol. It may be methyl alcohol, it may be ethyl alcohol, it may be propyl alcohol. Any alcohol vapor you need to use. Any alcohol vapor we need to use so that it will cause quenching. So this what is all three: ionization chamber, proportional chamber and Geiger-Müller chamber.